Hi, how's it going? Just a quickie today, a small quality of life improvement. So here's our setup from before. We can run this. And we see our statue is good, is nice, it works. So here's something we can do to refactor the code and maybe clean up a little bit as the code continues to grow. Let's go to our structs and I'm going to create a structure called a deletion queue. Now, what this will do is basically hold a queue with a bunch of function calls to delete objects. So when we create an object, at the same time of creating the object, we push its deletion function onto the main queue. And then at the time of finishing everything, we just flush the queue. Okay, so we're going to need a few things to do this. First of all, we'll need a double-ended queue. So that is this one, double-ended queue, because we're going to kind of push onto the back, I guess, and pop from the front, or however you want to think about it. Maybe push on the front, pop from the back. Either way, we need access to both ends. And we're going to be pushing on a bunch of function calls, and we could push them on as function pointers, but we could also use C++'s functional module, which makes this a lot easier and a lot more intuitive. So let's get started with this. By the way, this is basically using the code from Vulkan Guide. So check that series out. It's really, really good. vulkanguide.dev. So what this is doing is we have a double-ended queue, and the data which is stored in the double-ended queue is a function reference. And what this syntax means is the function is a void function. It doesn't return anything, and it also takes no parameters. So for instance, if I wanted to, I think this works. If oh, that doesn't work. Expected a, what? Let's not do that. If you want to learn more about this, have a look, read more deeply into C++'s functional programming style, and I guess I will as well, right? So this is a bunch of function calls, basically anonymous functions, which will be deleting objects. So the first thing we'll need to do is we'll need to be able to push a function onto the queue. Okay, so this looks a little bit funky. This sort of thing we've seen before. It's a signature of a void function which takes no arguments. Here we've got a double reference thing. Now, I guess the short answer is this is just what's needed. But what this is doing is it's taking a reference to a reference. So I'm not sure if this is correct, but we could think about it like this. In C, if we had just this, we'd be taking a pointer. And then if we did double star, we'd be taking a pointer to a pointer. C++ uses references instead of pointers more commonly, which simplifies a lot of the calls. But just, it is what it is. Again, if you look more into C++'s functional programming style, you'll see this is the convention. Next thing we'll need is a function which just flushes everything. It just calls all of the deletion functions. So we will get an iterator and step through that iterator. So what we've got here is rBegin gets the object at the beginning of the right side of the queue. Does that make sense? So that's going from the rBegin is the end position of the queue, and then rEnd will be the basically left position, because if you count from the back to the beginning, the end of the end is the beginning. Does that even make sense? Again, auto is letting the compiler work out what the type of the variable should be. That's perfectly fine. So this is stepping from the end of the queue to the beginning. At each step, the iterator variable stores the function call. Then when we stick on this star, this dereferences it, so actually calls it. So we call that, and then we've looped through the whole queue. We've called all the functions. Let's now clear the queue so that we're not accidentally calling them again. And that's it. That is all we need to define a deletion queue. Now let's go ahead and use it. So we'll go down. Okay, cool. And now if we go to Vulkan Engine, right down to the cleanup section. Now I'll have a look at this and I'll think, which parts can I throw on the queue? Well, I don't want to call cleanup, I don't want to push cleanup swap chain onto my deletion queue, because cleanup swap chain happens in two cases. First of all, when we just want to delete everything and end the program. But secondly, if we minimize or resize the window. So we don't want to have, what we're doing with the queue is we're throwing in functions and saying, I don't care, this is going to get called in the end. But we actually do care about that cleanup swap chain. So we're going to leave that as it is. But if we look down here, destroy sampler, I think we can actually put that onto our deletion queue. So we actually won't do that. But here's what we'll do. We'll copy the function and then we'll search for, what was it? VK create sampler. That happens here. Now, after creating the sampler, if this succeeds, like the if statement is successful, then we go. Oops. Okay, so again, another bit of syntax here. So what this is doing is basically baking in the function call. It's saying, let's create an anonymous function, which is equal to this. It takes no arguments. And the function definition goes inside the braces. And this is it. We've pushed that deletion on. So just to be sure. Okay. Let's put this in debug mode just so we can see if there are any errors. No errors, but that's fine because errors would happen when we end. So we'll end, and as we can see, nope, no errors. There is this error before, but that is not to do with the deletion queue. That's complaining about something else. Okay, so as you can see here, we now just put on a good podcast and spend the evening, what was it? Just spend the evening finding these. Okay, image view, that's not what I'm after. Texture sampler, no. Texture images, okay. So I tried actually putting this in the load image thing, and it just didn't work, so we'll do it here. Okay, so as you can see, it doesn't matter whether it is a Vulkan function or the member function of the class, this should still work. So we run this right now, and we look good, we exit, and that's fine. There are no extra errors. So let me just grab this. This is some code that I did before. Whoopsie, what happened? Okay, so here's how we can simplify the function. When we go to cleanup, we call cleanup swap chain. We flush the queue, and then we go up to about this point. I guess we could put more of these on the queue, but it's okay. After, oops, what was that? After this point, the order of creation of things starts to matter a little bit more. It's probably... Okay, so for instance, let's say... So I had some trouble pushing on destroy debug messenger. It's probably not the trickiest thing to work out, but it just wasn't working. And, well, we've simplified things a fair amount, so that's the idea. At the point, this new microphone sounds weird. At the point where we create something, we immediately store its deletion function ready to go, and we're good. We run this now. Great. Close it, and we are not getting any errors. Awesome. So we've cleaned up the code a little bit more. That'll be it for now. Have fun, and see you in the next one.